Welcome to my algebra class. We're on chapter 11, section 9, and we're going to be multiplying binomials with radicals. And if you remember FOIL, first term, outer term, inner term, last term, we'll be using that, and also the difference of two perfect squares and the trinomial square. So the first example is the difference of two perfect squares, where I have a minus b times a plus b, and the middle drops out. So what happens here is 4 times 4 is 16, and then the outer term is negative 4 radical 13, and the inner term is positive 4 radical 13. So they drop, and you just have your first and your last terms. So the square root of 13 times the square root of 13 is the square root of 169, which, if you realize, if you take the square root of a number times itself, you always get that number. So it's 16 plus 13, which is 29. They come out perfect squares. The second example is a perfect square, trinomial square. So we have 2 plus radical 7 times 2 plus radical 7. So first term is 4, outer term is 2 radical 7. And remember, the outer and inner are the same, plus another 2 radical 7, plus the square root of 7 times the square root of 7 is just 7. So we get 11 plus 4 radical 7. And the last one is another trinomial square. We have 2 radical 5 minus 5 radical 3 times another 2 radical 5 minus 5 radical 3. So if I take 2 radical 5 times 2 radical 5, I get 2 radical 25. But if you remember, radical 5 times radical 5 is just 5. I get 2 times 5, which is 10. Outer term is negative 10 radical 15. And outer term is negative 10. Inner term is also negative 10 radical 15. So those are the same. We get negative 20 radical 15. And the last term, negative 5 times negative 5, is plus 25 radical 9, which is a perfect square. So it's going to be 25 times 3, which is 75. So we get 85 minus 20 radical 15. And if you remember, if you multiply a radical by itself and you just get the number of the radical, you can save yourself a little bit of work. We're also going to encounter fractions that have a binomial in the divisor, in the denominator's place, and it has a radical in it, and we've got to get rid of it. Well, the only way we're going to get rid of it is somehow get rid of the radical 7. And to do that, if you remember back here, when I used the binomials that were opposite each other, I got rid of all radicals. That came out with just 29. So we use, and we call this the conjugate. So if I have 5 minus 2 radical 7, its conjugate is the other binomial that's positive. So what's going to happen, it's going to throw out the middle term, and it's going to make the last term a perfect square. So if I multiply the top, I get 15 plus 6 radical 7. On the bottom, the first terms are going to be 25. The outer term, 10 radical 7, and the inner negative 10 radical 7 go out. Remember that. And then you multiply the last terms, and it's going to be negative. So always the difference of two perfect squares. 2 times 2 is 4. And the square root of 7 times the square root of 7 is 7. So it's 25 minus 28, which gives me 15 plus 6 radical 7 over negative 3. So that's going to come out negative 5 minus 2 radical 7. I divided 15 by negative 3 and the 6 by negative 3. And that way I eliminated the radical in the denominator's place. Okay, we're ready to start the assignment. So you need your book open to 545, and we're doing 1 through 45. 1 through 34. So starting with problem number 2, we're to simplify. We have 4 plus radical 11 times 4 minus radical 11. First term, this is the difference of two perfect squares, is 16. The outer and inner drop out, and the square root of 11 times the square root of 11 is just minus 11, which gives me 5. Problem number 4, the square root of 19 minus 9 times the square root of 19 plus 9. Again, the difference of two perfect squares. So we're going to get the square root of 19 times the square root of 19 is 19, minus 9 times 9, 81, gives me negative 62. Problem number 6, the square root of 15 minus the square root of 3 times the square root of 15 plus the square root of 3. First term is the square root of 15 times the square root of 15 is 15. Minus the square root of 3 times the square root of 3 is 3, which gives me 12. Problem number 8, we have 8 minus the square root of 6 quantity squared, which is 8 minus the square root of 6 times 8 minus the square root of 6. So first term, 64. Outer term, negative 8 radical 6. Inner term, also negative 8 radical 6. It's a perfect square trinomial. And negative times negative is positive. Square root of 6 times the square root of 6 is 6. So I get 70, adding the 64 and 6, minus 16 radical 6. Problem 10, 4 radical 10 plus 3 quantity squared is 4 radical 10 plus 3 times 4 radical 10 plus 3. Multiplying the first terms, I get 16 times the square root of 10 times the square root of 10, which is just 10. Plus outer term, 12 radical 10, plus inner term, 12 radical 10, plus last terms, 3 times 3 is 9. So that's 160 plus 9 plus 24 radical 10, which simplifies to 169 plus 24 radical 10. Problem number 12, we have 3 radical 7 minus the square root of 3 quantity squared. So that's 3 radical 7 minus radical 3 times 3 radical 7 minus radical 3. First terms, I get 9 times the square root of 49, or 9 times 7. Outer term, minus 3 radical 21. Inner term, minus 3 radical 21. And last terms, plus the square root of 3 times the square root of 3 is plus 3. So that's 63 plus 3, which is 66, minus 6 radical 21. (14), I have 3 radical 5 minus the square root of 2 times 3 radical 5 plus the square root of 2. They're exactly the same except opposite signs, so the middle terms will drop out. So 3 radical 5 times 3 radical 5 is 9 times 5. And I ignore the outer and inner terms. And negative 2 radical 2 times positive radical 2 is negative 2. So that's 45 minus 2, which is 43. Problem 16, I have 8 radical 11 plus 2 radical 6 times 8 radical 11 minus 2 radical 6. Again, same binomials, opposite signs, so outer and inner terms drop out. Multiplying the first terms together, I get 64 times 11, because radical 11 times radical 11 is 11. And the last terms, I get minus 4. Radical 6 times radical 6 is just 6. So I get 64 times 11, which is 704 minus 24, which is 680. Problem 18, I have 6 radical 2 plus 4 times 3 radical 2 minus 5. There's no special product here, so we just use FOIL. First term is 18 times 2. Radical 2 times radical 2 is 2. Outer term is negative 30 radical 2. Inner term is plus 12 radical 2. And last term is negative 20. So I have 36 minus 18 radical 2, adding these two together, minus 20. So that gives me 16. 36 minus 20 minus 18 radical 2. And remember, you can never do anything with 16 minus 18 because you have to multiply by the radical 2 first. So it's kind of like different terms. Don't try it. Number 20. We have 7 radical 13 plus 2 radical 6 times 2 radical 13 plus 3 radical 6. Again, use FOIL. 2 times 7 is 14. Radical 13 times radical 13 is 13. Outer term, 21 radical 6 times 13 is 78. Inner term, 4 radical 78. And last term, 2 times 3 is 6. Radical 6 times radical 6 is just 6. So 14 times 13, 14 times 13 is 182. 21 plus 4 is 25, radical 78. And 6 times 6 is 36. So adding the 182 and the 36, I get 218 plus 25, radical 78. Problem number 22, I have 8 radical 6 minus 2 radical 3 times 2 radical 6 minus 3 radical 3, using FOIL again. 8 times 2 is 16. Radical 6 times radical 6 is just a 6. Outer term, negative 24 radical 18, multiplying the 6 and 3 together into the radical. Inner term, negative 4 radical 18. And last term's negative 2 times negative 3 is positive 6. Square root of 3 times the square root of 3 is 3. So here we have 96 minus 28 radical 18 plus 18. And 18, that's 114 minus, there's a perfect square in 18, which is 9. So 3 times, take that out, 3 times 28 is 84, radical 2. So our answer is 114 minus 84, radical 2. The next set of problems, we have to rationalize the denominator of each fraction. So problem number 24, we have 1 over 2 plus the square root of 3. So we need to get rid of that square root of 3. The only way to do it is to use its conjugate, which is 2 minus radical 3 over 2 minus radical 3. And that's a form of 1, so it doesn't change the problem. So on top I get 2 minus radical 3. On the bottom, remember the outer and inner terms drop, so I get 2 times 2, which is 4, minus, I don't know why I have a 2 there. Square root of 3 times the square root of 3 is just 3. So I get 2 minus radical 3 over 1, or just 2 minus radical 3. 26, I have 1 over the square root of 7 minus 3. Get rid of that. We need its conjugate, which would be the square root of 7 plus 3. Multiply, get a form of 1 and multiply that out. So I get the square root of 7 plus 3 over the square root of 7 times the square root of 7 is 7, minus 3 times 3 is 9. So this comes out the square root of 7 plus 3 over negative 2. And since we don't leave the negative sign at the bottom, we bring it up, so it's going to be negative radical 7 minus 3 over 2. 28, 4 plus the square root of 5 over 3 minus the square root of 5. We need to multiply by its conjugate, which is 3 plus radical 5. On the top, we'll have to use FOIL. So 3 times 4 is 12. Outer term is 4 radical 5. Inner term is 3 radical 5. And the last term, square root of 5 times the square root of 5 is 5. And on the bottom, 3 times 3 is 9, minus the square root of 5 times the square root of 5 is 5. So on top, we get 12 plus 5 is 17, plus 7 radical 5 over 4. So our answer is 17 plus 7 radical 5 over 4. 30, we have the square root of 5 minus 2 over the square root of 3 plus 1. We need to multiply by its conjugate again, the square root of 3 minus 1 over the square root of 3 minus 1. The numerator, we use FOIL. Square root of 5 times the square root of 3 is the square root of 15. First term. Outer term is negative radical 5. Inner term is negative 2 radical 3. And last terms is plus 2. Negative 2 times negative 1. And that's over the square root of 3 times the square root of 3, which is 3. And 1 times negative 1 is negative 1. So we get the square root of 15 minus the square root of 5 minus 2 radical 3 plus 2. Can't add anything there, all over 2. And that's our final answer. There's nothing else we can do with it. 32, we have 5 over 3 radical 7 minus 5. Its conjugate would be 3 radical 7 plus 5. So on top, I would have 15 radical 7 plus 25, multiplying everything by 5. On the bottom, 3 radical 7 times 3 radical 7 is 9 times 7 minus 25. So that gives me 15 radical 7 plus 25. That's 63 minus 25, which is 38. And that's my answer. And the last problem, 34. We have 6 minus 2 radical 3 over 3 radical 2 plus 3. Using its conjugate to eliminate the radical 2, we get 3 radical 2 minus 3 over 3 radical 2 minus 3. Using FOIL on top, we get 18 radical 2, outer term, minus 18, inner term, minus 6 radical 6, and last term plus 6 radical 3. On the bottom, 3 radical 2 times 3 radical 2 is 9 times 2, minus 9. So we get 18 radical 2 minus 18 minus 6 radical 6 plus 6 radical 3. 18 minus 9 is 9. So we can simplify that and cancel everything with a 3. So 3 goes into 18. 6 radical 2 minus 6 minus 2 radical 6 plus 2 radical 3 over 3. So I'm canceling out 3's here. And that's my final answer. That concludes the evens. Be sure you check the back of the book for the answers to the odds.